NASA announced last month that the Artemis 1 mission would be delayed due to Tropical Storm Nicole. More so, there was a fuel leak in the spacecraft. These problems raised the possibility of the mission not taking off. However, the mission took off and was successful, reaching farther than the earlier Apollo 17. Stay till the end to find out the mission progression and who the astronauts aboard are. They may be humans or mannequins. On Tuesday, November 15th, while the Space Launch System rocket waited for liftoff on Launch Pad 39B at the Kennedy Space Center in Florida, sensors discovered yet another fuel leak. These types of leaks were the bane of this rocket's existence during previous launch attempts. And when another leak occurred during this countdown, it appeared to all that we would witness yet another scrubbed launch, or worse, a rollback to the vehicle assembly building for repairs. Yet that's not what happened, as the spectacle in the Florida skies early Wednesday morning, November 16th, proved. As the world watched to see if NASA could repair this fuel leak, Artemis 1 mission managers made a risky decision. They sent a red crew, a specialized team of technicians, to what engineers call zero decks, at the base of the fueled rocket to try to stop the liquid hydrogen leak. They repaired the leak successfully, and the SLS launched on November 16th. Do you know the cost of this rocket? It's $4.1 billion apiece. That's a massive amount of money. So these are some of the problems that delayed its launch. But despite all those problems, the rocket did lift off on Wednesday, November 16th at 1:47 a.m. Eastern Standard Time. The Space Launch System blasted off from the Kennedy Space Center, and we were all prepared, as we had seen simulations of what it would look like. Seeing this rocket take off was mind-blowing. It leaped off the pad in a way that other rocket systems just don't. So much power, and it shouldn't have been surprising, right? SLS has these two giant solid rocket boosters. It has 4 RS-25 engines powering the core stage, and there's a lot of power in this rocket. More powerful than the Saturn V, more power than the Space Shuttle. It flew, and the entire launch was smooth. We saw the solid rocket boosters detach at the right time. The rocket pushed through the dynamic maximum pressure, separated the core stage, and extended the solar panels on the European service module. After that, the upper stage fired for 18 minutes, putting the spacecraft on the right trajectory to go to the moon. At that point, it also deployed 10 CubeSats housed in a ring connecting the upper stage and the spacecraft. Everything went perfectly, but we were nervous over here because we feared something could fail. This rocket had never been flown before, experienced 2 hurricanes, and had to be driven back and forth from the vehicle assembly building to the launch pad. However, it was amazing how smoothly the entire process went. On day 5 of the journey, Orion entered the gravitational influence of the moon, and on day 6, it made its first flyby of the moon, coming within just 130 kilometers of the surface. It then fired its thrusters, picking up velocity to carry it on a unique trajectory around the moon. As it was passing the moon, it flew almost directly overhead 3 of the Apollo landing sites, and then it flew behind the moon, and we lost contact with it for a while. Still, Orion coasted out to the highest point away from the moon. On day 13, it was about 432,000 kilometers from the Earth and about 65,000 kilometers from the moon. The distance was the farthest a human-rated spacecraft had ever flown. However, it isn't entirely true. The Apollo 10 capsule, Snoopy, is probably in orbit around the Sun somewhere, so it's gone farther. On day 16, it fired its engines again, putting it on a trajectory to return to the moon. Now, while it was on this flight, the astronauts tested Orion's real purpose. There were many different techniques and technologies that NASA was looking to practice during this mission to make sure that they would all work. For example, when humans were on board the Orion capsule, they tested all the different thrusters on the capsule, trying different modes of flying the spacecraft. During Artemis 1, they kept track of all of the radiation sensors on the exterior of Orion and the radiation loads the simulated astronauts were receiving. Since they were flying so far from the Earth's protective magnetosphere, it's just out of the star tracking system so that it would know where it was even if it couldn't receive telemetry information from Earth. The spacecraft was equipped with 16 cameras and had essentially modified GoPros on the ends of the solar arrays. It also includes many cameras inside and outside. This feature allowed them to live stream almost the entire mission. The spacecraft returned to the lunar sphere of influence on day 18. Once again, it was out of contact with Earth for about 4.5 hours. On day 20, it made its second flyby of the Moon, passing again within about 130 kilometers of the surface, and it fired its engine for almost 3.5 minutes to put it on course to return to Earth using the Moon's gravity as a slingshot. A propellant test was another experiment that they conducted both at the beginning and the end of the mission. They rotated the spacecraft to see how the propellant sloshed around inside, both when the fuel tanks were full and when they were almost empty. By the end of the mission, Orion had used less fuel than NASA expected. It used about 5,500 kilograms and still had about 1,000 kilograms in reserve. As Orion approached solar maximum, just before reaching the Earth's atmosphere, it separated from the European Space Agency's service module, which had supplied it with power and additional resources throughout the entire mission. Now Orion was on its own. It entered the atmosphere above the Pacific Ocean, going about 40,000 kilometers per hour. When compared to orbital velocity, which is about 28,000 kilometers per hour, it's much faster going from the Moon into the Earth's atmosphere. This attempt was the second time that an Orion capsule was tested. The first was launched into orbit a few years ago, traveled around the Earth, and re-entered, so they were confident that the landing system was going to work. And so on Sunday, December 11th, it landed in the Pacific Ocean off the coast of Baja, California. The spacecraft floated in the ocean and was met by the USS Portland. It was brought on board for a return to port. The flight lasted 25.5 days, completing a 2.2 million kilometer journey. And, as an interesting coincidence, this day matched exactly the 50th anniversary of the Apollo 17 moon landing, which was the last time humans set foot on the Moon. Now that Orion is safely on the ground, we can look back and see how the overall mission went. And we've got to say it was almost close to perfect. There was one part earlier in the mission when NASA lost communication with the spacecraft for about 45 minutes. That was a little unnerving, but they were able to restore communication, and then there were no more problems apart from the times when it went behind the Moon, which is what they were expecting. The launch itself caused a lot of damage to the launch pad. Perhaps the biggest loss of the mission was the CubeSats we mentioned earlier. It released 10 CubeSats onto the same trajectory to the Moon, and within a few hours, it was obvious that many of them had already gone offline. Another one went offline a few days later. At this point, about half of the CubeSats carried into space with Artemis 1 have gone offline. Nevertheless, the Artemis 1 space launch extensively explored the Moon. While the Apollo missions provided humanity's first hands-on look at our nearest celestial body, NASA returned to the Moon with Artemis 1 for much more than basic exploration. The program laid the groundwork for unprecedented activity on the lunar surface, including a human base camp, a series of nuclear reactors, and a mineral mining operation. NASA has made it clear that it wants to develop a lunar economy. The space agency has also established the Artemis Accords, a set of principles for exploring the Moon that more than 20 countries have joined. Although Orion did not have a crew, it is flying an instrumented mannequin to measure radiation exposure and the stresses a crew member would be experiencing on a flight to the Moon and back. One of the stand-ins, the only full-body example, was named Commander Munikin Campos, after the late Arturo Campos, who during the Apollo 13 mission wrote the emergency procedures to transfer power from the Apollo lunar module batteries to the command module, enabling Odyssey to have enough electricity to reach a safe splashdown. Campos, who died in 2004, was the electrical power subsystem manager for the lunar module, and his colleagues on the Mission Evaluation Room and Mission Operations Control Room were awarded the Presidential Medal of Freedom for their efforts. After some series of delays, the Artemis 1 finally took off and landed back successfully, thereby making history as the farthest flying human-rated spacecraft. It also provides the foundation for moon habitation through its extensive research.